Hello and welcome to Spur Gear Design. In this video, we're going to talk about how to do the basics of a design for Spur Gears, some potential applications that you can use with 3D printing, and some of the dimensions that you can design for yourself. So, as you can see here, this is a straight Spur Gear design, and this can be utilized in a rack and pinion aspect where you have a rotating gear that would go around being pulled by the teeth. But that's a different story altogether, and we'll show how to design that down the road. But essentially, it has several different angles that you can utilize, and as you can see here, I use a 20-degree angle from the horizontal or the center line, and essentially there's two other degrees you can utilize, 14.5 and 25. Now, this may not be applicable to you if you're doing something for aesthetic reasons, but if you're trying to get certain fits, you might have to play with these angles to see what rotates best. So that's where some of the playing around might have to be a factor. But this is just some of the dimensions that I was able to pull from some charts. So we're going to take a look at the drawing that I made that can give you at least a good starting point if you want to design your own gears, and let's go from there. So here you can see in this drawing that we have several different pieces of information that can help you when it comes to making your own version of a gear. So the diametral pitch is something that you would base a lot of your dimensions off of. Now, a couple different key factors that it'll give you is your circular pitch, which is your center to center distance. And as you can see down here, you have a formula that is pi 3.14159 over the diametral pitch, and that will give you your center to center distance. Your addendum, which is your small a from the top to the diametral pitch line, is 1 over pitch. So if it was an 8, it'd be 0.125. For the addendum b, you see that it's 1.2 over pitch plus 2 thou, 0.002. Please realize these are in imperial, not in metric. And then the last one you can see is 0.2 over p plus 2 thou. Now that is the clearance, and I usually use the clearance as the radius as well, just because it's an easy enough thing to utilize, but obviously you have to use your own gauge for that. So this is what it would look like if you want to design your own portions of a gear, at least to start off with. Let's take a look at what two Spur Gears would look like interlocking to give you an idea of how they work. So in this, you can see that I assembled two of them together and colored them red and blue, but essentially you can see that that radius is in there, but it's not touching the teeth, and you have a nice gap so that when you do utilize a gear, you have spacing so that they don't interlock and bind. So that's why you need to have a clearance. And if you go back to that drawing, you can see that that's why there is the addendum is a different formula compared to the addendum. So hopefully that helps. If you have any questions, please feel free to leave them in the comments. Otherwise, this is Tyler with 3D Printer Store, and I hope you have a great day.